PS5 on your desk for me. I'm going to go ahead and start. I also have yours in a folder that I had thought was the press started pressing. I'll pull yours up on a Chromebook. All right, guys. Sorry. We have broadcasting coming. Shush. Please stop your conversation. Thank you. Broadcasting is coming to video us for the activity for the share-a-thon. So I told them about 10 minutes in. So we do need to go ahead and jump on this, and then we're going to go over to PS4. Hold on. Go get what you need. Thank you. I don't know. Probably on like the global news or something. All right, so I'm just going to call on you. Sometimes we have a difficult time getting started. Let's see here. Who's got me? Blink. Brandon. I was calling you, Brandon. Can you tell me what happens when an electron jumps from a lower energy level to a higher energy level? That is jumping to the excited state. Good term for that. How did it get to the excited state, Tiana? What did we do to it? Okay, so lightning bolt, got it. Okay, what else? Heat, what else? Or photons, highly energetic photons. All right, so is it absorbing or releasing energy, Colin? And as it gets to the excited state, did it absorb energy or did it release energy to get there? It absorbed the energy that we shocked it with or whatever. Okay, so as it's dropping from a higher energy level to a lower energy level, it's definitely going to be doing what with energy? Releasing it, okay? How can we detect that's releasing energy? Thank you, good. So you can see the light. That's only if it's in the visible spectrum, but we might be able to see light. We'll see the light, guys, today multiple times, so that we can actually detect that the energy is being released. Okay, you guys have the blue sheets in front of you? Yes? Look for the transition from n equals 4 to n equals 2. If you don't have one, share. All right, n equals 4 to n equals 2. The chosen one is Chloe. All right, 480. Is that what it is? You gotta look really close on this thing. 4. I'm sorry, I got it like real close. 4 to 2. Can you guys see it? 486. I didn't hear you. Yeah. Okay. I thought it was a different one from what my other class told me. 486, yes. Does everybody see 46? 486. What is the unit on there? Look towards the top. Yes, towards the top of the Bohr model it says nanometer. Right. Thumbs up if you can see how to read this little darn thing. I just need to make sure everybody knows how to read that. I will make, this is what I give you on your test. On the actual exam, they give you a big one. Yeah. On number 4? So do you see that one of them drops all the way down to n equals 1 and one of them drops all the way down to n equals 2? They drop to different locations. And that's what you're looking at, the one from N4 to N2, which is the shorter one, which is 486. Okay, yeah. So we basically just looked here. All right, with me. We basically looked at the n equals 4 line, and there's 1, but that one drops all the way to n equals 1, so that's not the one we're looking for. You look at the other one, which is here, n equals 4 to n equals 2, which is that inner core there, and you draw the line down till you see which wavelength it's correlating to. In this case, it's 486. Okay, good. I don't want you, this is a tool, you should know how to use your tools, okay? On the other questions here, this obviously that you've been looking at is called the Bohr model of hydrogen. It is only true for hydrogen. We give kudos to Bohr for finding out a lot of this stuff about the orbits and where the electrons exist, but we couldn't replicate it for any other element. Not very useful. Useful for hydrogen, but not other things. So we had to build upon that. So Einstein, de Broglie, Schrodinger, Heisenberg, Planck, and probably some more people, helped build the quantum mechanical theory, the quantum mechanical model. And so there's a difference between these two theories. You should be able to answer some of these like specifically on multiple choice. Okay, so Bohr assumed motion of the electrons were in these things called not holes. It's so similar. It's just orbits. Okay, Bohr's model called them orbits, and they were set pathways with set energy. In that pathway, you can see it on the model. There's a path that's set, and there's an energy associated with that, so it's a set pathway and set energy for that electron. Not very different, but somewhat different, is the quantum mechanical theory, which decided that the electrons exist in a cloud, and we have a word for the cloud. It's called orbitals, right? We couldn't get much different, right? So the orbitals, they look different, though. They're not set pathways like this. They have funny shapes, like the spherical one, which looks like it's called S. The S, the has a letter that's assigned to every orbital. The S orbital has a sphere shape to it. You might want to draw these. Okay, just sketch them with me here. Okay, the P orbital has like a kind of a dumbbell shape to it. The D orbital has a double dumbbell shape to it like that. So I'm trying to, they're supposed to look 3D. I'll kind of like do some sketching here. Okay, so you can see that they're getting bigger. So the S is a sphere, the P is just a dumbbell, the D is a double dumbbell. So I'm trying to help you with the like D double dumbbell. Okay, remember that. And the F orbital looks like a flower. About as good as it gets there. Okay, so it's got a bunch of orbitals, kind of like a flower. So F looks like a flower. So F for flower, D for double dumbbell, P for dumbbell, S for sphere. Sphere makes sense with the S too. Okay, so I'm trying to associate the letter to the shape I've given it. But they have all these locations everywhere where they think the electron can exist, but they don't know exactly where it exists. Bohr says it's in this orbit. They're saying it's in this cloud someplace. And we'll jump into the quantum mechanical model a lot more when we hit modern, which is coming very soon, after we finish our light discussion. Okay? So let's look at, now do I still have concept for? Yeah. Did I give that concept for yesterday? No. Morgan?
Attention teachers, if you have any seniors in your room who have cards that need to go to the CPR training, please dismiss them to go to the auditorium at this time. Thank you.
All right, let's grab these concepts real fast, guys. So work with me here. I'm going to give a little stack to each little area. Please pass these out to your comrades. We're going to check over concepts. You guys pass this out. I'm not sure if that's right. Oops, I'm sorry. Thank you. It's also when I have colors. Oh, I'm just trying to look. Keep around out for these. Here. It's not your time to be
What is something done? Ooh, another
Yeah. Here, Alvin, pass out here. Vincent, can you help Alvin? Okay, Alvin, pass me some of those.
I don't know how many.
Oh, look, you're learning people. Who are we at?
I do know Avery.
Here, give me some of those. Give me some of these. Ryan!
Ryan.
Excuse me, sorry. Brandon. Guys, youthmom.com. Can I help? Can I help? And PS4. PS4. Not PS4. PS4. Okay. I'm going over matching first, all right? Here we go. The reason I like to go over these very quickly for you is it's a good study tool specifically for multiple choice, okay? So, do you have something to write with? If you didn't turn PS4, you better write it down, turn it in late, okay? 1T. Give me a thumbs up, like every time I just want to see, okay? 1T, 2S, 3R, 4P, 5N, 6O, 7Q, 8I, 9K, 10M, 11J, 12L, 13D, 14B, 15H, 16C, 17F, 18E, 19A, 20G. You got like most of those. Maybe you missed up one. Okay, good. Good. That's really good for multiple choice. Okay, so for one on the true false now, so go back up to the top section. You guys tell me. 1. Never true. Good. 2. Sometimes. Good. 3. Always. 4. Never. 5. Actually, I think the best answer is always, only because this one says an atom. It doesn't specify ion. If it said ion, then you could say it had a charge. But it said atom, so I'm sticking with always there. Terminology, right? Okay. 6. Never. The mass of an electron, oh, hold on. The mass of, sorry, it says mass of electron. Mass of electron, you guys made a little chart on reading guide for. The mass of electron is really, really low. It's almost negligible, so we usually ignore it. So the mass of electron is never equal to the mass of a neutron, ever. They're totally different. 7. Always. 8. Never. Good. 9. Sometimes, because on this one, you do need to look. Let's see, it's number 9. So on the P share, nitrogen weighs 14, so 7 plus 7 is 14. But they're isotopes of nitrogen, and they can weigh more or less. So that's okay for it to be different. So sometimes it's different. 10. Always. 11. Always. 12. Never. 13. 13 is actually always. So I don't have, yes I do, laser. Okie dokie. I'm going to point at the periodic table over here. Do you see the towers? Look on the wall up here where I'm pointing. The towers for group 1 and 2. That's representative elements part 1. The other towers over here, all of these are the rest of the representative elements. So they're the tall columns. This little short column here, this little set here, are called the B elements. If you look on your periodic table, it'll say like 1A, 2A. Skip all these guys. 3A, 4A, 5A, 6A, 7A, 8A. The A groups are the tall groups. The B groups are the short groups. Okay, so that's answer 2. 13. 14 is always true. 15 is never true. Okay, so that's good for you guys for studying. Good. Okay, scientist people. You guys have your scientist people? Yes. Scientist Hall of Fame. Okay, so we are going to, this is the simplest way to share this. And so I call it a share-a-thon. So if we choose a partner now, look at them. So your partner set is going to partner with another partner set. Okay, so if you guys are partners and me and Casper are your partners, we're going to share our partner, or our scientist, and then we're going to talk for maybe 2, maybe 3 minutes, and then you guys are going to share your scientist. It's very informal, so it's 4 people in a group. So, but you're attached to your partner, like Lou, so you're going to then rotate to another group, and then I'll say rotate again and rotate again. So we'll probably get to 3 or 4 rotations. Okay, after that, so you're going to share about them, and some of these I might, usually on something like this, I'll give you guys extra credit. I'm sorry, I will offer extra credit on your test, and I'll say, tell me something about what you learned from your Science Hall of Fame. And it might be something about something else, or about somebody else's project, or your project. So you can share about anything, okay? So it shouldn't be more than 5 minutes. I will put a timer on the board. I have this like brown paper outside the room, and you guys will just take your person down, and then put your name beneath it, your partnership name, and then I'm going to hang them on the wall after this. Okay? So I'm going to put timers on the board. Partner up with your person. If your person is not here, pull up what you have on see online on the internet, go grab a Chromebook, and then we're gonna get started in 1 minute. So partner up. I want you to share it like this, and I will post it later. I want you to do the share it like that. Okay.
Because that was one thing I was going to ask you when I was looking at your website.
Give me some time because I need to have you make that up another time.
Okay.
You guys should have talked before today, though. I want you to partner up with a group and tell about what you learned when you guys did it. You just won't have a visual. Okay? Oh, no, yeah, I do. I want you to bring it in, but right now I can't do anything about the lack of it not being here, you know what I'm saying? So I want you to practice by working with other people. I got you. I saw him this morning, so let's go here. Yeah.
I was custom to you, sure.
I printed all of them that I have. Do you guys have it on mine? Let's get it on up here. I'm sorry. I printed out, unless it's in my junk mail, they'll find other resources. Okay, let me log out. Sorry about that. There, Elvin, you're partnering with them? And this, okay, you're gonna partner with them in a second. Gals, I want you guys to sit in with a group. So split yourselves up, sit in with a group, okay?
Okay,
All right, take 30 more seconds in this pairing, okay? Take 30 more seconds in this pairing.
Are we?
Okay, senior attention, 5, 4, 3, 2, 1, great. Okay, so broadcasting, they're going to be doing here. So you guys, the next round, you're going to share with each other, a new partner, a new group in the hallway. And the people that I've asked to share here, are going to share. And I'll do another rotation. Okay? So I asked this group, and that group. You guys want to stand here. We're going to share for about a minute each. Okay, less than that. Everybody else go to the hallway and do the next round. You're on your Oh. Alright guys, okay guys, do me a favor, line up that way. I'll move that. Okay, guys. I will hold that closer to you. Oh. We do have a lab here. We do have a lab here. Okay. I would this for your own personal safety. Okay. Get over there. Okay. Alright, is this stuff in the way? Make sure you guys talk loud. Okay. I'm trying to get you guys ready. Okay. We are on the national news station. Okay. So you're just gonna hold up. You're going to hold up your posters and talk about the person, maybe what they were, like what country they were from. Okay. What country they were from or ethnicity. You want to say anything, and then why you highlighted them. Okay. Talk in here and talk loud.
Sorry?
Yeah, talk really loud.
So like, can I talk like this? Like, I'll be good.
Should we close the door?
So I talk like this?
Let me shut the door. All right.
Alright, this is Sandra B.J. Campbell. She was born in New Mexico, but she's Native American. I chose her to be in the science hall of fame because she brought power and electricity to tribes that developed renewable energy sources to tribal lands.
So this is George Washington Carver. He was born in Diamond, he was an African American. In his earlier years, he wasn't accepted in college because he was a slave, but his master's wife taught him how to read and write, and he grew through a passion for agriculture. He was not the inventor of peanut butter, but he did make plus products from peanut butter, like kernel and so that was so cool. George Washington Carver was significant to the Hall of Fame because not only did he ignorant, but he didn't want to give up on hope. He wanted to help people.
Talk a little louder.
We chose Jim first African American professional recognition, public acceptance in the field, and was the first African American degree in meteorology.
Okay. Okay. You guys, thank you so much. Sorry about that. You guys are gonna go post your papers around. You'll see what to do. Okay, I'm gonna send it. You have your first grade, you have your take yours. I will print yours and we'll just set it, make a space for yourself. I'm gonna post it around. I'll send another group. Okay. Actually, you know what? Can we, Casey and Alan, can we split up again? Okay. Yeah. I don't know longer side for me. Just. Got you. Okay, let's post it separate. Yeah.
attention, teachers. Please put your recycle bins outside the doors at this time. Thank you.
Do you want them to bring them in here or in the hallway? There's 4 posters. You can just do it. Like this. You can just like, yeah, panoramic, scan it or something. Whew. It's a little bit rough around.
started out by talking about how and the experience and Alex, like you just have something in there. And then she was telling Alex was like, I'm done. I'm not.
My video's on.
Sorry, I didn't mean to. Oh, yeah.
12:30. That was like 2:00.
Okay.
Honestly, I went.
You honestly thought that's what it just happened.
I know.
A solid 70 minutes.
It went 5 minutes.
Sorry. You don't need help. Just put it near the Chromebooks. Pull out a piece of paper and write down this conversion. I got you. And then I'll have yours. I'll look for yours. Okay, I'll look for yours.
What's wrong with you?
Okay, here we go, guys. We have a lab, so I need you to get the paper out, write down this conversion. That's on the board. There are 2 versions of it. I write down both of them, so it doesn't matter which one you use as long as you use it correctly. In our lab today, we are actually going to measure the wavelengths of light with spectroscopes. And the way a spectroscope works is that it has a diffraction grating on it, and it splits light into the many ways of data. And I think I have almost a spectroscope for everybody to use in the lab. I'm going to have light across the majority of the lab because you have different light back here. You have incandescent lights, you have fluorescent lights, there's a mercury light above us, you can see this light back here, and the spectrum, the gas discharge tube, I'll be turning on. So the way a spectroscope works, you know, I'm usually Steve Gonzalez here. You look into the light. You look into the light with this little slit, tiny slit on the end of the spectroscope. And on the other side, there is a diffraction grating, and it shows you the bright light spectrum just like this. So we've seen some of these kind of, but not colorful pictures in black and white. So what these measure in though, these lines in here, they'll say like 4, 5, 6, 7. Those are not angstroms, which is this symbol up here, nor are they meters. They don't have a measurement. So what we have to do is when we see a line in here, let's say we see a 4, let's say the violet light's at a 4, we instead say that's 4,000 angstroms. And that's on your lab sheet, so don't worry, it's on there. But then you would convert angstroms to meters. How would you do that? How would you convert angstroms to meters? Multiply by. But where, so what am I putting on top specifically? 1 times 10 to the negative 10 meters, and that's equal to 1 angstrom. Okay, so that's 1 angstrom, and that allows you to cancel angstroms out so that you can get to meters. And then guess what you can calculate from wavelength? Everything. Frequency and energy. Okay, so if you don't know how to do that, use your notes. The spectroscope lab is in the notebook. I will help you as you go around. 2 things to know though. Every bulb is different at every lab station. The incandescent bulb is the one that's not coiled. The compact fluorescent bulb is the coiled one that's actually a person. And then every other group has a frosted bulb, which is colored. It's like red, yellow, black light, stuff like that. And then the mercury vapor light, or the mercury vapor is in the fluorescent tube that's above us. Okay? Let's do this. It's the same lab groups as being in Hey, Colin, everybody tell me a light says, as people read, they're gonna say, the white fluorescent light, that's the white fluorescent. This is the incandescent light. Everybody's lights gonna be on because they're gonna be rotating around. Okay. That is the black light, that's a black. You do not have to go in order, stick around, okay?
Is there another parallel? Wow. The thing it makes it look like a
That one you're there's steps way this way. That is the compact fluorescent. So this is the non-coil. That one's coil. Oh, you said violet. So they're all lines. So it's like line, line, versus this one. Same thing with this one. See and believe in me. You gotta look at these things. You gotta be involved. Oh, we have to go.
Yeah, purple, blue, yellow, green. Oh, that's fine. It's this question. So white fluorescent, but you gotta.
This is a compact fluorescent. This is one you can
Well, this one.
You might want to set closer because there's some contaminated light everywhere.
Yeah, this one's line. It's like red. Okay, see how you look at it and like go left? It's like, wait, you gotta, it's like, the numbers are kind of on the left side. That's not which way? Okay, so it says this order of color bands from left to right. Make sure you have the sections. Vehicles order on the fluorescent. This is how you do it. How is it? No, yeah, that's good.